Hey everyone, welcome back to our FlatBuffer tutorial series. In today's video, we are going to build our very first FlatBuffer object using Python. We'll walk through the steps to create and populate the object, understand why it's memory efficient, and see how to serialize it for storage and transmission. So let's quickly have a recap. FlatBuffers are a fast, efficient binary serialization format that is developed by Google. They are designed for performance-critical apps like games, mobile apps, IoT device, and more. Unlike JSON or XML, FlatBuffer allows us to have access data without parsing or unpacking, which makes them super quick and lightweight. So before we create an object, we need to initialize the FlatBuffer object. The builder is the core component that handles memory allocation and object construction. So let's create a Python file and start doing it. Also, let us create a folder. First of all, name the test script to place all our test scripts in it. So let me right click and create a directory, name as test scripts. You can name anything, but for the, I'm just naming it as test script. And then we'll create a py file named as persons object, in which we'll try to create the persons object, which we had seen in the last session. So let's name it as person object and dot py. Py will be the extension. So this is our Python file. The first thing we need to do is import FlatBuffer as we are going to use it. And if we have not installed FlatBuffer, we can do it by using pip. So it's the simple command pip install FlatBuffer that will install FlatBuffer. So you just have to go to the terminal and you have to say pip install FlatBuffer. So it will help you install FlatBuffer. So as I've already done it, I will just skip this part and I will not be doing it. And the second thing is we have to create the builder object. So we'll do it by builder flat buffers dot builder and we will specify 1024. So this line creates a buffer with a starting size of 1 KB, which can grow automatically if needed. And now comes the fun part, which is populating the object. In FlatBuffer, we start by creating the leaf data first, that is string or any of the nested object that we need to define. We build it before the main object is being built. So in our last FBS schema, that is person schema, if you see here, let me open it. We can see here for building a person object, we need three attributes and we will have to initialize all the three attributes. So we'll start by initializing the name string. So let's give a variable name as name. And here we have to specify builder dot create string. So there is a method builder dot create string. And here we can specify the name of whatever name you have to specify in that object. So let's take any name. So we'll take Steve. So we can also initialize the ID and age because that is the int form. But let's see how can we do this. Then we'll create the object by adding the other attributes. So let us start by specifying person start, and then we'll have to builder. So this initializes the creation of a person's table. And right now we are seeing some error, but let's see. Let's build the object first, and then we'll remove it. Then we'll have to. So before that, let's see the file file that is generated. And if you see the file file, if you can see here, there are different methods defined here to. So this is the person start method that we have just called. And then there's person's add ID, add name, add age. So these are the method which we'll be using. And then we'll be defining the attributes. So for adding ID, let's call person add ID. So name of the method should match by the whatever we have in the py file. And then we have to builder dot and the value. So here ID is a numeric value. So we can specify 1001 or any other value for now. Then we'll in the similar fashion we will do persons add name. And if you're not knowing this particular methods, you just have to go to the py file and copy the name. And you just copy it here and put it here and then just specified builder. And if you see here, we already have specified name in the earlier variable, so we'll be using the same variable here. So we'll specify the name variable in here, which will get us the value as this. Then again, we will use the next method, that is persons add age. So in this object, there are only three attributes. So it is simple to understand, but going forward, we'll see some complex object as well. And right now, I have not specified any age variable. So here I have to give the age. So let's assume it's 30. And then we have to end this object. So what we can do is we can add this with the help of person, and let me specify P capital and then builder object. And let's take it into a variable called as person. Now the whole object resides in this person, and this specifies the creation of the person's object. It will tell the builder that I've added all the fields. Now close this object and give me a reference to it. So this person is the reference. This person's object is now a reference within the builder that can be used to for a final output, or nested. It can be nested inside another object. So this pattern may feel reversed at first, but it's optimized for how developers lays out the memory. So if you can see this person start method, we are seeing this error. So we have to import this person start, or otherwise there is another method. Just put in person dot in front of it, so that this error goes on, and then import the person class itself. So let me put it, and then I will import this person class. If I import this, if you see, I have to just specify its location, and you will be using this one. So it imports person directly from FBS MyApp, which you can see here in this path. Okay, let me see. Person's add ID. So let me see whatever the method we use. Let me call it. Okay, there was some grammatical mistake. Okay, so the object is created now. Now here's what FlatBuffer sends. Once we have built this object, it doesn't need to be passed. You can read the field directly from the memory. And it means that there is lower memory usage and no garbage collection over it. Super fast access times. So it's always perfect for real-time or low latency applications. Once our object is complete, we finish the buffer and write it to a binary file. So that can be done by specifying builder. So we have to use the builder object and its finish method. Finish. Let me spell it. And in here we have to pass in the object which we have created, that is person. And we have to take this in some buffer object. So let's write it down, then I will explain. Buff dot builder. And so let's write this output to a file. So for this, we will specify with open. Let's give a name, person.buff, person.name, and specify the read write operation. We have to specify workbook. Here we have to build buffer. Okay. So this bin file is compact, portable, and can be used across different platforms, even on mobile or embedded device. So in this way, we can write the output to a particular person's .bin file, which can be used in further operations. Also, now if you want to read it later, so just load this file and use the generated code to access the data directly. So if you want to read the file, yes, we have to do it like in this way. So just let me copy this particular thing. We just have to change the method. So we have to write f dot read in place of write. So in this way, we can read the data as well, and we can print it. So in order to print that data, we have to specify persons dot person dot get root as person. So if you see in this particular person, there is one more method to get a root as. So we have to copy this method. Okay. And here we have to specify bus hyphen 0. Okay. And then we have to whatever we need to print. So let's print out persons dot, or we'll print out all the names which are all the attributes which we have specified. So let's print out persons dot name, and then we need to specify. Let's copy this and change it to ID and age. Okay. So no deserialization is needed to access the data, and we can just instantly access the data by just specifying this read method. So let's run the script and check if we can get the desired output. Let's run the script. Okay, so we have got an error, and this error, let's see. So it usually means that the file buffer Python code was not generated correctly, or the model structure is not being used properly. So to fix this issue, let's check by step by step. So the first step is that we need to check whether our FBS schema is perfect. So if you see here, we have perfectly defined the FBS schema, and there are no errors in this. So this can be skipped for now. Second is we need to see whether the persons.py file is correctly generated. And this is also correctly generated as we have generated it using FlatC. So this is also not an issue here. Then there can be a third way. It is by connecting the Python import and the way the methods are imported. So if you can see here, this we are seeing an error. So as we did earlier, we can correct it by adding persons in front of this, and then if you can see the error has went away. So we might be wondering that why we added the extra person text in the step. That is because the generated persons.py defines get root as a person inside the person class and inside the person model. Hence, adding an extra person solves this import issue. And now let's run the script to check if we provide the right output. So let's see whether we are getting the name and other attributes in the output. Okay, so this byte array object can be interpreted as an integer. Okay, let us see. Let us check what we have missed. Okay, so a small mistake in here. We need to take this help of equal to f dot read. Okay, so while reading, we need to do some changes. Okay, so we are reading and we are taking this in this buff object, and then we are passing it to the get root as first. This object is being passed to the next method. Let us run now. Um, buff is equal to f dot read is not supported. Okay, let us solve this as well. Okay, one more issue. So we have copied this, and here we need to mention as RB, so read from buffer, and this is write to buffer. So let's run it. And if you can see here, we get the desired output. So whatever attribute we have provided initially, all the attributes we can print it here, and we can pass it on to means we can use it in the further operations. So if you might now be saying that we are with the help of particular print method, an extra B is being printed, and it indicates that the value is written as a byte, not as a string. So this is a typical behavior being here using FlatBuffer in Python. And if we need that, we need to create and print the exact value that is being passed. Then we need to change this particular print method and we need to decode it. So we can do it by adding a dot decode hyphen UTF hyphen 8 in this. Okay. So we need to convert the byte to a string by using this decoding, and then we can get the inner output. So if we can right click and run this object, we'll see. So if you can see, now we are executing the exact value which we have passed. So if you want to change and see, if we change it now, and if we run this script again, we get the exact value which we have passed. So now in the next one, if you can see here, we are getting the exact values. So to recap, we have created a flat buffer builder. Then we have built and populated an object in here. Then we have serialized it to a binary file, that is buf. And then we have read back the values by using this particular method, or by using this particular code. So we can write to the buffer as well, or also we can read. So yeah, that's much. So in next video, we are going to a step further, and that is by handling nested tables, vectors, and there are pretty much very much other stuff that we need to see in the case of flat buffers. So if you found this video helpful, give it a thumbs up and don't forget to subscribe. And let's continue in the next lecture. So see you in the next one. Thank you.